go, get ready for this. This is one of the more difficult problems to solve. Question 4.2 for the November 2019 paper. So this takes a bit long, so let's get on it. Here's the question. We've already done 4.1 where we filled the array called ARR maze with, and that is ARR maze there. We filled it up with lines from the text file. Remember, the lines from the text file, they look like this, and we also displayed it. So we've done that part already. Okay, now we are going to, so we've done the part where we displayed the maze into the rich edit, and now you can see what each array box looks like. The array, you've got each item of the array 1 2 3 4 5 6 7 8 16 has got a string inside which has got different characters in it, hashes and dashes and the @ sign. Now in this question we have to go and find which is the we've got to find a corridor. Basically an open space is represented by a dash. So the maximum number of consecutive horizontal open spaces, or in other words the highest number of dashes in a row consecutively, one after the other. We have to find which is the highest number in a row in this array and display that in the statement, and also display the rows that contain the maximum number of horizontal open spaces, or the number of dashes, the highest number of dashes that occur one after the other. So it's quite a tricky problem to solve. If we look at the output here, you'll see for maze 1 the longest corridor has got 7 spaces in a row, so 7 little dashes together joined up, and the array boxes over here, you see these are the numbers 1 to 16, those are the indices of the array AR maze. The array boxes number 2, 4 and 13 contain 7 consecutive 2, 4, 4's got 7 dashes one after the other, 2's got 7 dashes one after the other. So that's going to be quite tricky, and this is how I propose that we do it. And of course here's output for maze 3. The longest corridor has got 11 spaces, and that is number 15. There's 11 spaces one after the other, or dashes should we say. Okay, so that's quite a tricky problem. We know what's required of us. We know we have an array of 16 boxes, and each one is containing a big long string. The string has got 17 characters in them in total. So the array consists of all that, and this is array maze. So can you see there's 16 boxes here. I haven't got all the strings inside. I'm just demonstrating here that we have in each box of our array we have a selection of dashes and hashes and so on. Okay, now we want to count the number of dashes. Now let's consider that we have the first box, and we're going to make the first box S line 1, or we can call it ARR maze box number 1. If we so wish, we can call it that too. So this is going to take a while. I hope I don't take too long with this, so just try and bear with me here. So ARR maze, we're going to make that, we're going to call it S line, okay, box number 1. So that's box number 1. So for each time we're going to go through each character of this string. This is a string now. This is not an array. This is the string that's in the array box. And we're going to go through each character of the string. When we see a dash, we're going to increment a counter. So we'll get our count dashes equal to 0, and we have our longest line as well. We made it equal to 0 as well. So before we go through the string, okay, when we see a character that's not a dash, we won't do anything. We're actually going to set our count dashes equal to 0. When we see a dash, we'll increment our count dashes. So when we see that dash there, I'm going to make that our count dashes equal to 1. Then I'm going to ask the question, is our count dashes greater than longest line? If it is, we're going to set longest line to whatever our count dashes is. So I'll set it to 1 here. Okay, so that's now in box number 3. If that is a dash, we'll increment our count to 4 dashes. And then we'll ask the question, is longest line greater than our count dashes? If it is, then we're going to make our longest line equal to our count dashes. Then we'll go to the next box, the next character of the string. If character number 4 is a dash, so we'll increment our count dashes. And then we'll ask, is longest line greater than our count dashes? If it is not, then we make longest line equal to our count dashes. So there we have it. Now we go to character number 5. Character number 5 is a hash. So if character number 5 is not a dash, we're going to set our count dashes to 0. Character number 6, that's not a dash, so we set our count dashes to 0. Character number 7, that's a dash, so we increment our count dashes to 1. And we ask, is 3 greater than 1? No, so we'll keep our longest line equal to 3. Then we go to the next character. That's a hash. So character number 8 is a hash, so our count dash is set to 0. Character number 9 is a hash, so our count dash is set to 0. Character number 10 is a hash, so our count dash is set to 0. Character number 11 is a dash, so we increment our count dashes. And we ask, is longest line greater than our count dashes? No, so we leave longest line as it is. Go to number 12. That's a dash, so we increment our count dashes. Is longest line greater than dashes? No. So we go to the next character. That's a hash. Is that a dash? No, so we set our count dashes to 0. Is number 14 a dash? No, so we set our count dashes to 0. Is number 15 a dash? Yes, so we increment our count dashes. And we ask, is longest line greater than our count dashes? No, it's not. Then we go to number 16. Is that a dash? Yes, it is. So we increment our count dashes. And we ask, is longest line greater than that our count dashes? No, it's not. So longest line stays as it is. We go to the last character of the string, and that's an @. So we set our count dashes to 0. Now we do all of that. Now, once we've finished the whole string, we then go and put this longest line into an array called AR dashes, into the first box. Now this is the first, this S line is the contents of AR maze, the first box of AR maze. AR dash is going to be a parallel array to AR maze. And there you see AR maze is 16 boxes. AR dash is also going to have 16 indices, or indices boxes, if you want to call them that. And for each line that's in each box, we're going to do the same calculation here, just like we did with this line from box number 1. We're going to go to 2 and 3, and there'll be numbers here that we can basically go and put in for each one. And when we've finished all of that, we can go and then wait, let's make this 10. Oops, sorry. Just putting random numbers here, okay. 10, maybe only 1, some have 2, some have 5, maybe that's 6. So once we've gone through every single item in the array and gone through that using this method here, okay, then we'll go through this array of dashes, which is our parallel array to AR maze, okay, and we're going to go through each one and see which one is the highest and get it and put it into a variable called Rmax or something. And then once we've got Rmax, the highest Rmax, and we're going to go through the array again and see which one is equal to Rmax. So in this case you can see that Rmax is going to be 11, not so? So Rmax will be 11, and that's equal to 11, right? Once we go through this array and look for the highest number in AR dashes, we find that Rmax is equal to 11. Fine. Now we're going to go through the array again and pull out the indices of the numbers that are actually 11. So we can see that we're going to go through the array again, AR dashes, and pull out these row numbers 3 and 11, because that is what they want us to display. They want us to display the maze numbers, or other words, the indices of AR maze, which have the highest number of dashes in one line, like joined together. Okay, just the dashes joined together. It's quite a difficult program, but let's go and write the code using this method that I've just described here now. Okay, to do that we need to go through our maze array, from 1 to 16, but we're not going to use 16. We're going to use a for loop. Yes, let's get our for loop counter. We've got to go from 1 to, over here they've given us a variable called row count is 16, and arrow maze is array 1 to row count. So we should actually use that row count to go through our ARR maze. For k equals 1 to row count, do begin and end. Okay, now we're going to use the first box. We're going to say S line. We're going to get a string pull out each box, each contents of each box. So S line equals AR maze, square brackets k. Okay, we're using AR maze. Where's AR maze? It's a global array here that we filled with all the strings. Remember from the text file we did recently. Okay, so we get the first line, and the first line is going to look like this big long line. Okay, with don't know how many characters, probably 17, but you're not allowed to use 17. We will go for m. Let's use another for loop counter. I'm going to call it m. For m equals 1 to length of S line. I know there's 17 characters because I count them, but we're not supposed to. We've got to assume we're going to use 1 to length of S line. Okay. Now we're going to go through each box at a time. I know I've left space here because I'm going to do some initializing of variables. Remember I said that we got our longest line. Well, let's say our longest line starts at 0, eh? So let's make our longest line over here as a variable. Our longest line. We're starting at 0. Our longest line is going to be 0, initialized to 0. That's the longest so far. We haven't gone through the string yet. Now we're going through the string with the m, the for loop with the m for loop. We're going to ask the question, if S line character m, if it's equal to a dash, then we're going to do a couple of things. We're going to say we're going to increment a counter for dashes. Now I haven't declared a counter for dashes yet, so I suppose I better do, hey, count dashes. I must go and set it to 0 before I do anything, and I'm setting it to 0 over here just before I go through each AR maze content. So the array of this for k loop is going through the array of the ARR maze. Okay, so we get the first box, get our count dashes to 0, and m, the m loop, for loop, is going through the length of S line. The character S line character m. So we set m S line equal to AR maze box number k, and then we're going through S line. If it's an m, we increment our count dashes, but we also have to ask the question, if our count dashes, so we can keep track of the longest line, our longest line, if it's greater than our longest line, then we're going to do what I showed you over here. We're going to set our longest line to whatever our count dashes is, okay, like I described. Then we're going to say our longest line equals our count dashes. Okay, but what if it's not? If it's not equal to m? Well, it could be anything else, eh? So else we're going to, remember I said we were going to initialize our count dashes to 0. So if we get a hash or we get an at, then we're going to say our count hash dashes equal to 0. So we can start counting again when we get the next dash. Else our count dashes equals 0. Now that is done, but what are we going to do with our longest line? Well, our longest line is going to be the longest consecutive row of dashes. We discovered that when we did it here mechanically. We're going to now go and put it into our array. We're going to make an array of dashes, AR dashes, and go and put our longest line value into the box of the array of dashes. We have to declare an array of dashes here. Local array is good enough. ARR dashes colon array 1 dot dot, guess what, our row count. Just like AR maze, it's called AR dashes. It's basically going to be a parallel array to AR maze of integer this time. And if you want to go and declare it globally up there, you can do too. Doesn't matter if you put it here, if you go and put it over here next to AR dashes. Maybe that makes more sense to you. By the way, you don't need to have that space there, but yeah. Anyway, so there we have an array of dashes. Doesn't matter whether it's global or local actually. But before we go to the next box of our array of maze, we're going to go and fill up ARR dashes. Guess what? Box number K, because we're dealing with box number K of AR maze. So box number K of dashes is going to be equal to our longest line. And there we have an array of dashes, the number of dashes for each box of ARR maze. The highest number of dashes in a line for each box of ARR maze. And this is done before the end of this for loop that goes through the array. So I'm going to put a mark here, end of going through ARR maze. And this end is end of going through a line. Okay, so going through a string. That line, that string. So we're going through each box of each character of this S line. If it's a dash, we'll increment our count dashes and then we go and set our longest line to whatever our count dashes is. Doesn't matter if our count dashes is 1, we'll go and set our longest line to 1 and we'll carry on until we get to 3 as I demonstrated over here. Then at the end of all this, before we end the whole process here, we've now gone through every single box of the array, and every box of AR dashes will have a corresponding value. For instance, for AR maze number 3, AR dashes will have 11 dashes. That's the longest consecutive number of dashes, and so on. So each box will have its number corresponding to the box of AR maze. AR dashes will have 6 for 16, and 6 for box number 16, 7 for box number 9, and so on. And they are parallel arrays. Now we can go through AR dashes and see which one is the highest. So we can use a for loop to go through AR dashes. For now I'm going to use K. For K equals 1, 2. How many boxes? Our row count. Remember our row count. There we go there. Up here, see? Our row count, AR dashes. We're going to go and say if. And we must have a variable here called rmax. Let's make a variable called rmax. Rmax colon integer, or r highest, whatever you want to call it. If, and I'm going to set rmax equal to 0 here, but initialize it. This is a local variable, integer. So if ARR dashes square brackets k, if it's greater than rmax, then rmax will be equal to, we'll have a new highest, AR dashes square brackets k. So after this code here, I could put begin and end here. I'm only doing one thing. Just remember that this if statement is one long line. Eh? It's one long line. There it is. Your if statement is a long line until you reach the end and the semicolon. There we are. I don't need begin and end here because I'm only doing one thing, and that's that in this for loop. But now in the next for loop, we're going to now go and find all the numbers of boxes that are thing. But before we do that, let's go and put our heading. As I say, we have to say the longest corridor with 11 spaces in rows is. We have to put a heading in up there now. Red question 4 dot lines dot add. Take note, this is just before the end of this button click event here. We're going to now put in the longest corridor, and we must put a S here because it could be more than one. The corridors with the longest, with the longest, what do they call it? I call it number of dashes, but spaces. And we have to say the corridors with let's say plus int to string max rows okay, we basically got to put max there. We have to display what max is, and then we're going to go through each box of our ARR dashes and see which one is equal to max. Yeah. So for k equals 1, 2, row count, do. Okay, fine, I'll put begin and end here just to make us all happy. Begin and end. If ARR dashes square brackets k equals max, then we will display it in the rich edit. Question 4 dot lines dot add int to string, and we will display what? We're displaying the k. The k is the index number, or should we say the can you see the index numbers are displayed here, 1 to 16. We're displaying the index number that matches, that has the highest, that's got equal to max, the highest value there. So as I said here we got max equal to 11. Okay, so in this case box number 3 and box number 11 will be displayed. So this is our array of dashes which we built up after doing through this whole process of here, through each line of the array. Each line, for each box of the array had this big long line in it, and we went through each character of that line, and then we did this for every single box of the array, going through it, counting the dashes seen in the longest line, and then putting the longest line in its corresponding parallel array with AR maze. Okay, so now we can know that this particular box number 3 and box number 11 in this case both have the highest number in, which is max, which is 11. So that is the end of that program. Now we're going to run it and see if it matches the output of our question paper. We do need to do 4.1 first, so let's display this maze array 1, and then they say the corridors with 7 rows, so it's 2, 4 and 13, so that's maze 1. Let's go and have a look at maze 1. Yep, 7 spaces, 2, 4 and 13. Let's go and look at maze 3. So maze 3, display maze, longest corridor, 11 rows is 15. There it is. Right, that's done. I'll try and do it without looking, and I will see you all next week.